Okay guys, back for the calculator part. It says we got a picture of f prime. They want to know on what intervals is f increasing. There is no actual right answer here because the correct answer would be -1 to 2 and then 2 to 3 because that's the places where f is positive. In absence of the correct answer, I choose the most right one. They actually do this quite a bit, so that's why I kept it on here and did it. Here we've got the rate at which water leaks from a tank in gallons per hour is modeled by R. So R is measured in gallons per hour. And then they were curious about what the best interpretation of R prime of 3 is. So if R is in gallons per hour, then R prime has to be in gallons per hour, or gallons per hour squared. So we have the amount of water that is leaked out of the tank. Nope, it's definitely not an amount. The amount of change in gallons per hour, definitely not in gallons per hour. The weight at which water leaks from the tank in gallons per hour, definitely not. So D is the only one that says gallons per hour. So literally just with the units, you can answer that question. 78 says a particle moves along the x-axis. The velocity of the particle time t is given by v of t equals that function. If the position of the particle is 1 when time is 2, then what is the position of the particle at time equals 4? So this function x of t has points t comma x. So x is an output, which a lot of times bothers people. We have a point 2,1, we have a point 4, I don't know. So this is the velocity. So in order to find the position, I've already got this entered into my calculator. And we're going to calculate the integral from 2 to 4. So I'm going to say second calculate 7 because I'm trying to go from rate back to value. I'm going to go 2 to 4. So I get 0.353. That's not my answer though, because I've got to add that to 1, which is how I get the 1.353. Okay. On to 79. So this is in which of the following intervals on which is f is continuous but not differentiable. So f can be not continuous, or recall, with a hole, a jump, or an asymptote, and it can be not differentiable with any of those plus a corner point or a vertical tangent. So I see a corner point right there, which is on 2 to 3. It says the first derivative of a function here is given for -1.5 to 1.5, and which of the following intervals is the graph concave up? So I'm going to go ahead and put this function in. So I've got x squared plus 1 times sine of 3x minus 1. And I'm going to graph this real quick, so I'm going to go ahead and set my window. They said from -1.5 to 1.5, then I'm going to hit zoom 0. That's going to show me a picture of this. Now this is a picture of the derivative, and I want to know when the function is concave up, so that's when the second derivative is positive. So I'm looking for all the places this has a positive slope. So to me it looks to be right here and right here. So I go look at the answers and see if I need to do any more work, but I don't, because it's definitely that first one, because this is definitely -1.5 to something real close to -1.5. So I'll take A. 81 says during a rainfall, water in the tank increases at a rate modeled by this, which is in centimeters per hour. Says where t is the time in hours since start of rainfall. Says how much did the depth of the water in the rain gauge increase from t equals 0 to 3. So all I have to do is plug this function in to my calculator and take the integral. So I'll take 0.5 plus x cosine of pi, then x squared, or x to the third, divided by 80. And then all I'm going to do is do the calculation. So I got to go back to a normal viewing window. I'm going to hit zoom 6. It's going to take a minute to graph this. And then they're just interested from 0 to 3. So I'm going to hit second calculate 7 from 0 to 3. And I get 5.401, which is my answer D here. We'll try to sneak one more in. 82 says let f be a function f of 1 equals -2, f of 5 equals 7. Which of the following conditions ensures that f of c equals 0? So we just want to make sure this function crosses the x-axis. If it goes from a negative to a positive, all I need for it to cross the x-axis is for it to be continuous. The rest of this stuff is just fluff. This is the intermediate value theorem that we learned a very long time ago. All right, guys, I'll be back for 83 on.